Hi there, and welcome to our lesson 7 in our C1 topic on carbon chemistry. And today we are going to be looking at alkenes, which are another family of hydrocarbons, and how they are able to form polymers, which are long chains of hydrocarbon that can be used for plastics and clothing and various other things, which we will move on to later on.
Okay, so our objectives for our lessons on alkenes to polymers are: by the end of this lesson you should know and understand the name, the formulae and structures of alkenes and how alkenes are able to form addition polymers. Alkenes are similar to alkanes in the fact that they are hydrocarbons. Now, they have a slightly different structure, and the structure includes what we call a double bond between two of the carbon atoms. So what we're going to do is have a look at a few of the examples of alkenes. So the first one we've got here is ethene, which, similar to its alkane cousin, it has two carbon atoms. Now it has a double bond between those two carbon atoms. Now, because of that, we've got 1, 2, 3, 4 bonds, 1, 2, 3, 4 bonds on each carbon, as you have with the alkanes. Now this gives a molecular formula of C2H4. Now the next one is propene. Now again, similar to the alkane cousin, we've got 1, 2, 3 carbons. However, a common mistake made is that we only have one double bond in here between the first two carbons. So we've got 1, 2, 3, 4 bonds on here, 1, 2, 3, 4 bonds on here. Now one of the misconceptions or common mistakes people make is they put double bonds on each of the carbon atoms. There is only one double bond. Now the name for this is propene, and it has the molecular formula C3H6. Now we're going to have a look at one further alkene, and this is butene. So like its alkane cousin butane, we have 1, 2, 3, 4 carbons, and again just the one double bond between the first two carbons. So this is called butene, and it has the molecular formula of C4H8. Now you might have been able to work out that the general formula is CnH2n. Now often you get an alkane and an alkene produced in the cracking reaction that we've seen earlier in the topic. Now how do you test for an alkane and an alkene? You add bromine water to the two alkanes and alkenes. Now if you have a positive test for an alkene, you will get the bromine colour, which is orange, disappear. And what we're going to do is have a look at how that happens. So here we have the reaction of the alkene. Now this is ethene, and there we have the bromine molecule. Now what you can see is the double bond is able to be broken by the bromine molecule, and we then have a single bond between the two carbons, and a bromine attaches to each of the carbons. Now because we've no longer got this bromine, we no longer have the colour of the bromine. So to summarise, if you have an alkane which is saturated, there'll be no colour change. And if you have an unsaturated, which is an alkene, then it will go from orange to colourless, so you do have a positive colour change. Now polymerisation is the formation of a polymer. Now poly means many and m means molecule. So what polymerisation means is you make many molecules. However, it is in reality only one molecule. Now it's one very, very big molecule made from many, many molecules. So what we're going to look at is how we can actually form a polymer. Now on the screen here we have a polymer of polyethene. So we've got an ethene molecule here. Now the N that we've got here means that we have many millions and millions of those ethene molecules. Now they can react and they will form a polymer here. Now you can see here this is just a section of the polymer. So we've got this square bracket to show the polymer or the monomer that it was formed from. So because we've got two carbons, we then have the polymer polyethene. So what we've got then is a monomer at the beginning here, which is the ethene, and then on this side we have the polymer, which is known as polyethene. Now in order to do this, in order to make polyethene, you need a couple of conditions, and they are a high temperature and a high pressure. Most alkenes are able to make a polymer. Now what we're going to look at is when we take propene, which is this molecule here, and we break the double bond here to make a polymer. Now we've changed the structure slightly, so we've got a similar structure to the ethene where we've got our double bond here. However, you'll notice that the H that was here has changed to a carbon with 3 hydrogens. So this carbon with 3 hydrogens relates to this carbon with 3 hydrogens. Now when we react our n number of these, we will form this polymer, and you can see that you've got the same structure, however you've got the CH3 from here. So our monomer for this is propene, which makes our polymer polypropene. Now you will see as well that you have the name of the monomer in brackets to show what it was made from.
Okay, so we have looked at the naming of the alkenes, and it's exactly the same as with the alkanes, except you have an "ene" at the end. Now the key thing to remember is that there is only one double bond per molecule, and that goes between 2 of the carbons. We then looked at the reactions with bromine to form a bromoalkane, and that's where we break the double bond and cause the decolorization of that bromine. We've then looked at addition polymerisation, where we make polymers from monomers. Now poly means many and mono means single or one. So you start with one molecule and then you make a giant molecule of many of those called a polymer. And we've looked at the formation of polyethene or polyethene and polypropene. Anyway, I hope you've enjoyed this and I'll see you next time. Bye bye.